Just wanted to do a quick video. There won't be a huge number of video lectures for this class. This class has always been very self-directed by the student. And I'm more of a facilitator than anything else. This class isn't open yet. It will be very shortly. I don't have the syllabus ready yet, and I wanted to make sure I had that up. I published this beforehand just so you had access to the OddBall. Later there'll be some video lectures or a assignment sheet that's very clear about the personal project proposal, the belt grinder, and the Model Mania assignments. And that's really about all there is for this semester. The projects are fairly large and complicated. Don't let the fact that, oh, there's only 6 things. They're big things. OddBall. This is from a book from a machinist magazine. It used to be, I think it was called Home Shop Machinist. This is a 6-cycle engine. It's pretty cool. It takes, it's got a spark plug. It has points, carburetor. You build everything but the spark plug and the points and the screws for the most part. And there are springs. There's a spring here and a spring here, and there's 2 springs on the flyball governor. Things to note on this particular assignment. The gears you will configure in Toolbox, and I will have a video on how to do that. It's not readily apparent how to do it. You can't just use Toolbox. Wish you could, but you can't. We're going to use Toolbox to get the outside profile of these gears in order to extrude them. One of these gears, if you really wanted to, you could configure it in McMaster-Carr, but you can only do one of the 2. And actually, I think it's just as easy to just steal the outside profile and extrude it to what you want than to try and download what exists and modify it. You will be drawing some fairly complicated parts. There will be some fairly complicated assemblies. Again, springs we're not going to do. You don't have to draw the spark plug, and you don't have to draw the points. The plan set in comparison to 32 tall, this thing is magnificent compared to that one in terms of the pictures. Some things that people tend to wig out about. Yes, there are 2 flywheels, and they are joined together, and the crank is on a crank pin that goes between the 2 flywheels. So the 2 flywheels create the void that the connecting rod actually travels in. What you will find in here is how they machined them, because that was the nature of this magazine. A lot of that will give you some hints on how to draw it. Here's a subassembly picture. There are words on here. The words are very important. Read them. Because the first thing I'm going to ask you when you ask me a question is, well, what did the plan set say? Because I've drawn this, and I had a couple of questions, but as I put it together, they answered themselves. First thing, do you need to have these little dimples cut on the ends? Well, not necessarily, but in order to turn this on a lathe, I would have to center drill it. So do you have to draw it? I guess not, but when the part is done, it's going to look like this. I want you to figure this out. This is not that hard. People have a really difficult time with this. Look at the pictures, read the words, and do understand that picture 14 is kind of the finished part. 15 is where it starts, where they find the edge, and then they drill the hole, and then they rotate it with a pin, and then they come in and machine a tangent, and then they do the other side, and it's over. It's not that hard, I promise you. The spacing on some of these gets a little bit weird, but that's okay. Just let the slop happen here in this thick spot or here in this void. And I also think that the hardware that is called out might not actually be able to enter here because this fin might be in the way. You might have to actually drill and tap this and have the bolt go through the opposite direction. And you'll see that as you try to do it. Lots of words, lots and lots of words. I didn't have that many problems with it. It's just big. It's a lot of parts. It's a lot of parts. And these chamfers, 35 degrees, they're called out. It's pretty complicated. There's a lot of features in here. Do the best you can. That just kind of keeps going and going, doesn't it? There is one dimension, and I'm looking for it. I think this obviously is not 90 inches in diameter. Proportionally, it will work itself out, I promise. 16th is what, 0.0625? And this is about twice the size of that. 90 inches in diameter is probably a little large for that. I'll let you determine that. The gears, there'll be an entire lecture on these gears. Just ignore them. You've got plenty of parts to draw before you get to the gears. When we do the gears, I'll also talk about fly ball governors and what they're for. It's a feedback device. Oh, gas can. You don't need to draw the gas can. You can if you want. Start drawing some parts. There's plenty of plates and things you can draw that, this is not a particularly complicated part. Neither is this. Neither is this. You can get those done. You should be able to get that first subassembly done of the sides and front and back and things like that and get to here relatively easily, I think.